5 minutes after each presentation for questions. And we start with Monu. And let me start by, well, welcoming everyone. And let me tell you, this is a session of the Simonsen Lecture. The Simonsen Lecture is a prize that is awarded to distinguished young economists in Latin America by the Econometric Society. This year, the prize has gone to Monu Prem. Monu is a professor at Universidad del Rosario in Bogotá, and he has a PhD from Stanford. And Christine Pinto, she's a professor at INSPER in Sao Paulo. Before that, she spent some years at Sao Paulo School of Economics, FGB, and she has a PhD from Berkeley. So congratulations to both. And well, we start with Monu. You have 25 minutes. If people have questions, you can type them in the chat. And Monu, if you want to interrupt and answer questions, that's up to you, or we can keep all the questions for the end.
If you write them on the chat, I have two of my co-authors of the paper here, so I guess they can be actively answering questions in the chat.
That's perfect. That's perfect. Okay,
perfect.
We can start.
Okay, so thank you very much, Irene, for the introduction. It's a great honor to give this Simonsen lecture. Thank you very much to LAMES for that decision. First of all, before going to the paper, let me thank all my co-authors. Here is a picture of all of them, or with whom I've been working for more than 10 years. And I think this recognition is not only for me, but also the work that I've been doing with all of them in different projects and in different papers. So that is the first thing. And now jumping to the paper, this is a paper with two of my co-authors who were in the pictures above. The first one is Miguel Purro, who is a fantastic student that we have from Rosario, who is now applying for PhD. So keep an eye on his application. And the other one does not need much of a presentation, which is Juan Vargas, a colleague from Rosario. So this paper is going to be about the local effects of landmine demining and what it's a landmine. It's an explosive that is buried under the surface and is triggered upon contact, and its main objective is either to injure or to kill. They are one of the most pressing challenges to post-war recovery and also have long-term consequences. You can think of communities having these landmines around the community, so they threat people's life, people's mobility. Also, they are in rural areas, so they can affect agricultural investment. Sometimes they are placed close to roads, so they can have impacts on access to markets. Think of this as some agricultural communities now that they cannot take their goods to the local markets. Sometimes they are placed close to basic services such as water. And moreover, they are placed, in the case of Colombia, very close to schools because the army would spend the night at school. So the schools became a military target as well during the period of conflict. They are very cheap to fabricate, especially if they are handmade. It can be around $3 to fabricate one of these landmines. They are widespread use in internal conflict. And think of this, or the way guerrilla think of this, is that you have a combatant or an army member who does not need any food, nor water, doesn't sleep. They can injure or kill, and moreover, they can create a lot of fear to the enemy because now they cannot move freely in this ground. There are estimates of more than 110 million mines buried today in more than 60 countries. Some of these countries are still in ongoing conflict. Every year, there are more than 26,000 victims around the world. 42% of them are children. So this is not something that only affects the fighting population, but also the civilian population. Every year, tons of money is spent in trying to demine, but still, some estimates suggest that if we continue at the same rate, it would take more or less 1,000 years to demine the entire country. This suggests that demining the entire world. This suggests that demining campaigns are one of the most pressing and likely profitable post-conflict policies that can be implemented by the governments in a context of post-conflict. Just to fix some ideas, this is how a landmine looks like in the context of Colombia. These are handmade. You can see that they have some tape. They have some plastic bags as well, some cans, and these are very cheap to fabricate, and also they can become even more dangerous. So in this paper, what we're going to do is to study the socioeconomic and political effects of demining in the case of Colombia. Why Colombia? Colombia is the second country in the world in terms of number of victims of landmines after Afghanistan, and is the number one if we think of these handmade landmines. We are going to exploit the yearly and the georeferenced demining events over a period of 15 years from 2004 up to 2019. And we will be studying two types of treatments in terms of the way things are demined or these events take place, and also two time periods. So the first one is going to be this comprehensive humanitarian demining, and think of this as NGOs coming to the community. They work with the local community. The community tells them where these landmines are supposed to be. Then the NGO starts clearing the land, and they do not leave until there is no suspicion of more landmines in these places. This started to take over in the case of Colombia after the start of the negotiations between FARC and the government. Then there is this other type of demining that also takes place around the world, which is this military demining that takes, or is partial demining that takes place during military operations. So think of this as the military needs to do some operation. As a byproduct of this operation, they find a landmine on their way, and they basically demine just that landmine. They do not care to basically clear the whole area or to work with the local community. We're going to exploit this in the period of pure conflict and also one after the start of the peace negotiation. We're going to focus on highly disaggregated local effects. So think of this as one unit is going to be one demining event, and we're going to look at 5 kilometers around this event. Why 5 kilometers? Well, that was a choice. We're going to show you that the results are basically the same if we play around with 2, 3, 4, up to 7 kilometers around the demining event. And we're going to estimate everything with this new literature on diff and diff with staggered adoption. What do we find? We find that after the post-conflict humanitarian demining, there is an increase by 13% in nighttime luminosity. In the literature, think of this as the literature think of nighttime luminosity as a proxy for economic activity. So this could be either economic activity or think of just activity around these events. This is very related with another paper in post-war Mozambique that also looks at humanitarian demining, and they also find an increase in nighttime luminosity as we do in the case of Colombia. We try to complement the evidence from that paper, trying to look at other outcomes that we think are very interesting and very relevant if we want to understand the overall effects of these humanitarian deminings. One, we look at population density. We find an increase in 3% in population density. We find an increase of 7 percentage points in math and reading test scores. And this is very interesting. As I said before, one of the main problems for students was that there were mines around the roads and also close to the schools. What we find is that most of these effects are coming from students now being able to go to school. And finally, one of the main goals of putting these landmines was to cover or to protect coca fields from eradication. So what we find is that after this humanitarian demining takes place, coca production drops. And if you don't know, basically coca is the main input for the production of cocaine. Then when we look at this partial demining that takes place during these military operations, we find no effect in nighttime lights, nor in students' performance. We find a decrease in population density and a decrease in deforestation. And the result of deforestation, it's very interesting because we find that this is mainly driven in areas that are suitable for agricultural activities that are extractive and that have been related to illegal groups. This is oil palm, also cattle ranching. We also have some evidence using illegal gold mining, finding that after this partial demining in these military operations, there is an increase in illegal gold mining in these buffers. Once we look at what happens during conflict, we find the same as in point 2, but we also find a decrease in nighttime light density. And the main story for this, or what we try to push in the paper, is that there is a relationship between demining and conflict in the case of Colombia, especially during this pure conflict period, because the landmines were used to protect the strongholds of these guerrillas. So once one of these mines are taken out, this increases the confrontation between the guerrillas and the army, and this has spillovers for the local population. That's why also population density decreases. In terms of contribution, I think the main contribution is to this kind of rising literature on the economic effects of demining. This paper by Chiovelli and co-author is very nice, and they look at the effects of humanitarian demining in post-war Mozambique in terms of nighttime lights. we kind of complement by looking at other outcomes that also we think are very relevant in the case of humanitarian demining, such as education, and also look at this other type of demining that is very common across the globe. And I think we touch on these other two literatures on the long-term of effects of bombing demining. In our cases, more the short-term effects, and also maybe landmines is one of the main mechanisms behind this relationship between economic activity and conflict. In terms of context, the conflict started in 1960s, or the conflict as we see it now in Colombia started in 1960s with the formation of FARC and ELN. FARC was trained in the Soviet Union, ELN in Cuba. As of today, there are 9 million people registered as victims of conflict. As I said before, Colombia is the country with the highest number of victims of improvised landmines in the world. And one of the main milestones in the last decade was this start of the negotiation between FARC and a government to try to raise an agreement of peace. And this basically moved Colombia to a new and more peaceful equilibrium with lower levels of conflict after 50 years of experiencing this conflict between FARC and the government. The FARC offensive activities dropped by almost 100%. The landmine victims dropped by almost 70%. And what is interesting for us is that humanitarian demining efforts started to pick up after the beginning of these negotiations. And that's why we're going to use two different periods to analyze what happens with demining. One, which is a pure conflict period from 2002 up to 2012, and a post-conflict period, which is from 2013 and onward. As I said before, humanitarian demining, the main goal is a full clearance of these areas, or at least that there are no suspicions of landmines in these areas. There are 5 international NGOs, 2 national NGOs, 1 by ex-FARC combatants. In contrast, military demining is a byproduct of another operation. They are usually working with dogs and with metal detectors, and if they find any landmine on their way, they basically demine it, but they do not care of leaving the whole area without the suspicion of landmine. As you might think, for humanitarian demining, there was some targeting because the government was deciding where to start doing demining. What we show in the paper is that basically in the 40 municipalities that have experienced humanitarian demining so far, the characteristics of these municipalities cannot explain the targeting. Most of these municipalities are very similar in terms of conflict, in terms of the incidence of coca production, in the incidence of landmines, and so forth. Of course, all the results that I'm going to show you is in this in-sample. So I think in-sample, we have a good measure of the impact of this humanitarian demining. If you want to extrapolate these to future areas that are going to get demined probably in 5 to 10 years, probably these effects are going to be an upper bound to what would happen in those areas as well. In terms of data, the first part was to create a good data set of demining. Of course, we got data for military demining from IMSMA. They have data from 2004 up to 2021. And all of this data was taken from military GPS. So basically, we're pretty confident about the exact location of this military demining. For humanitarian demining, we got the georeference data on areas that were cleared and also areas that are confirmed to have landmines and that are going to be demined via humanitarian demining in the future. And this is going to be important, of course, at the time that we try to implement our empirical model. As I said before, an observation in our case is going to be a landmine that got demined, and we're going to be looking at what happens around this area that got demined. We have 3 treatments, as I said at the beginning: the humanitarian demining and the military demining during peace and conflict. This is what I was mentioning to you before. If we look at characteristics of these municipalities and try to predict the timing at which they would be humanitarianly demined, we do not find any characteristics that predict them, and also for the intensity of the demining areas. For military, since they were not targeting to demine a particular area, and this is more of a byproduct of another operation, we are not that concerned about this. So in terms of outcomes, of course, the usual suspect when you want to do something that is very disaggregated is nighttime lights. And in the case of Colombia, it's very correlated with several measures of development, of economic activity, and so on. Of course, all of these at the municipality level. We're going to use the data of 1 kilometer by 1 kilometer from Lee. And this series corrects for all the known problems of nighttime lights. We're also going to have information at the population density, also at the 1 by 1 kilometer. And this is a random forest prediction that comes from disaggregated census, coupled with remotely sensed data, and also with some facilities in the ground. And this comes from a Stevens et al. Paper from 2015. Then the third set of outcomes come from education. And the main challenge here was to have a data set where we could geolocate all the schools. We did this by web scraping the data set from the Ministry of Education. Once we have the exact location of the schools, we merge with that all the outcomes from the national test scores, and this is called Saber in the case of Colombia. So we have that for grades 3, 5, and 9. This data set comes from goes from 2012 up to 2018. So we're only going to be able to do this analysis in the post-conflict period. We find that 96% of the buffers around humanitarian demining have at least one school, 70% of them in the case of military demining. And this already tells you that the location at which military demining happens and humanitarian demining happens are going to be different. And I'm going to try to deal with that in a couple of slides. Then in terms of other outcomes, more in the use of the soil, we find we use data from this global forest change from a Landsat satellite, and we have data at the 30 meters. This data set is coming from the Hansen et al. Paper. Then we're going to complement this with other measures of extractive activity. One is fires. In the case of Colombia, it's very common to just use fires to clear area and then put, for example, cattle in these areas or these deforested areas with fires. So we're going to use the data from the NASA measuring also fires at the geolocated level. We're going to have data on alluvial illegal gold mining that comes from the UNODC. And this is also using remote sensing data on top of some high definition photographs to kind of calibrate their model. Then finally, the last set of outcomes come from this coca cultivation data set that comes from the UNODC. And again, it's remote sensing tools plus high definition photographs that are taken through helicopters. So this is also at the 1 by 1 kilometer. So these are the main outcomes that we're going to use in the paper, but we're going to complement this with some information at the buffer level. We know the whole network of roads paved and unpaved for Colombia in 2012. So we're going to use that to play with some heterogeneous effect on road connectivity. Also, we have information on soil suitability, and we're going to try to use this information to try to understand whether this impact on deforestation is coming in certain areas that are suitable for these crops that are related to these illegal groups. And then we're going to complement with some information at the buffer level, things of climate, terrain, and so on. And of course, we have some information at the municipality level as well. So the empirical strategy, if I would have to write this paper or to run this paper probably 3 years ago, I would just run the usual two-way fixed effect model that would have a dummy at the event level and then a year fixed effect and the usual post-IT dummy. If we do that in this context, it's not a great idea. We see a large share of negative weights, especially for the military demining. Also, this forbidden comparison has a lot of weight in the estimator of the two-way fixed effect, being 27% in the case of peace, military demining during peace, and 11% in conflict. That's why we kind of moved and estimate everything with the paper or the method suggested by Callaway and Santana. In the paper, we showed that our results are robust to using at least 3 other estimators suggested in the last year for this case. So what are the main assumptions of this model? No anticipation. So basically that the potential outcomes for the treated and the untreated unit before the assignment of the treatment are the same. And the common parallel trend assumption that basically the evolution of the potential outcomes of the treated and the untreated unit in the case that they are not treated is exactly the same. So once we have these 2 assumptions, we can construct something that is called the ATT-GT in this literature, and is the average treatment effect on the treated for example, cohort 2004. So think of the landmines that got demined in 2004, and we're going to look at their effect in 2007. Then how do we construct this? We need a set of controls. We're going to use 2 sets of potential controls. One is these places that are going to be demined in the future, but are not yet demined. So for example, a set of landmines that got demined in 2007 is a potential control that we can use for the ones that got demined in 2004. And also we're going to have a set of never treated units, and think of these as landmines that got demined in 2020 and 2021. Our data set goes up to 2019, so we can use them as places that we know are going to be demined or that they host a landmine but are not demined yet. And we're also going to use these confirmed areas as never treated as well. And in the case of conflict, we're going to use 2013 as this never treated. We're going to use the balanced sample version of this estimator just to account for changes in the composition of the estimates. Then we're going to put all these ATT-GTs into an overall ATT using the simple version that they use in their model. So it's basically an average across G, meaning cohorts of treatment, and T, which is the year at which you're looking at the treatment effect. And of course, when we do this average, we wait for the size of the cell. And we're gonna combine also this to create dynamic figures. We're gonna partially assess the validity of the parallel trend assumption using these two new papers by Roth, basically accounting for potential biases in our estimate that comes from differential pre-trends, and also checking the sensitivity of our analysis to violations of the parallel trends assumption that can be linear or non-linear. So let's jump to the results. After demining or after humanitarian demining during peace, we find that nighttime lights increased by 13%. It's not 12% because of this correction that you need to make because the outcome is an hyperbolic scene transformation. We find an increase in population density of 3% once we compare it to the average of the dependent variable. We find an increase in the percentage of students that have satisfactory results in these test scores, increasing by 7 percentage points for math and by 8 percentage points in terms of reading. And this more or less represents an increase of 30% with respect to the sample average. For forest loss, we do not find any effect, and we do find a decrease in COCA. If I show you the figures, we find that for test scores, the figures look pretty well. In terms of nighttime lights, we do find this drop in -2. So that's why all these sensitivity analysis that we're doing, I think, are important, especially for this outcome. Then in the case of military demining during peace, we do not find any effect on nighttime lights. We find a decrease in population density, also that is more or less a 3% decrease. We do not find any effect on test scores. Here we have a couple of stars, but this effect is not that robust, so I wouldn't make much out of this result. We find an increase in deforestation, and we find a decrease in COCA. So something that can come to your mind is that maybe these two places where these two types of demining are taking place are very different. That in principle is okay. We wanted to understand what were the treatment effect of these two types of demining that take place around the globe. But if we want to compare them and see them more similar, something that we could try to do is kind of to increase the overlap of the underlying characteristics of these places that got demined via humanitarian demining and via military demining. What we do is we estimate a propensity score. Then we use this paper by Crump and Invens in Biometrica to kind of increase the overlap in the characteristics of these two types of deminings. Once we do that, what we find is the same results for humanitarian demining. If anything, the effects are a bit larger for nighttime lights. For the rest, we find basically the same. But now for military demining, we do find an increase in nighttime lights, even though it's more or less 40% of what we find for humanitarian demining. We still find the negative effect on population density with no effects in test scores, little increase in deforestation, and no effects on COCA. So the final result or baseline result is showing what happens with military demining during conflict. Remember that I'm using these two set of periods, one where conflict was in place and the other one where the peace negotiation started in Colombia. Once we look at military demining in this pure conflict period, what we find is that nighttime lights decrease by almost 2%. We also find a decrease in population density and an increase in forest loss, with no effects in COCA. As I said before, we do not have data for test scores for these years since it's not available in Colombia. We do a bunch of robustness tests. I just want to mention one because maybe you're already thinking about it. So of course, demining is not, planting a landmine is not something that is very isolated. So you can have landmines that are close to each other. So maybe there was one demining that happened in this place now, and then in the year after, there is another landmine that got demined that is very close to it. So potentially these are contaminated controls. Something that we can do is to drop all these contaminated controls and estimate our model again, and basically we find the same results. We try to account for differential trends based on characteristics at the event level, at the municipality level, also to deal with this idea of potential targeting of these demining events, and the results just go through. As I said before, we can use these three different methods for estimating, different radiuses, and so on, and the results are there. Another thing that you might be thinking is that there could be some other public policy that is implemented close to these areas that had humanitarian demining, and that's what is driving the effect and not the demining by itself. One of the ways of dealing with that, even though we don't have very good data on public policies that are implemented at the geographic level, is to use these ETCR, which are areas where the guerrillas or the ex-combatants went after they signed the peace agreement. And in these areas, of course, the government support them with some money to create their own productive activities and so on. So something that we do is to exclude any humanitarian demining that happen close to these ETCRs that are called in Colombia, to try to deal with this idea of potential more public policy or more public spending done in these areas that could potentially explain our results. So now let me jump to the mechanisms. What I'm going to do for the mechanisms is that I'm going to zoom into some pieces of results that we have in the paper to try to explain what could be behind those results. And the first part is the role of road connectivity. As I mentioned at the beginning, landmines are commonly placed near roads and also are an important obstacle for accessing school. So there are a lot of anecdotal evidence of parents not wanting to send their kids to school because of the potential threats of the landmines being in the community. So the removal of these landmines can exacerbate economic benefits if now the community can get to some local markets, and also if now the students can go to school. For this, we are going to use the road of network in 2012 in Colombia. We're going to have the network for paved and unpaved road. We are going to create two measures of connectivity. One, think of it as an extensive margin, and then the intensive margin. The extensive margin is whether a road passes very close to the landmine, and the intensive is how many roads pass close by to the landmine. Once we do this, we can kind of split the sample into those with high connectivity and those with low connectivity, and try to understand whether the effects are different. What we find is that most of this effect that we find in nighttime lights is driven by these areas that are connected. You can see this in panel A, but also we find the same effects for test scores. So we find larger benefits in terms of educational outcomes in those places that are more connected through roads. Of course, in some of the comparisons, they are not statistically significant, but more or less the story goes into that direction. We also try to understand what happened with enrollment, because this effect that we're finding in the benefits in terms of education can come from students going to school, or maybe they are learning more. So one of the ways to try to understand that is to see whether more students are now going to these schools, and that's exactly what we find. Now we are trying to get some information on educational inputs, let's say teachers per students and so on, to try to see whether the input function of education also changed after demining. But we're still working on that. Then now I'm going to try to understand what happens in terms of conflict after humanitarian demining. Something that we found, as I showed you before, is this decrease in population density and this decrease in nighttime lights after this military demining takes place. In the context of Colombia, these landmines were placed to kind of protect the advancement of the enemies. And once these landmines are taken out, there is confrontation between the army and the illegal groups. And moreover, because of the community knowing more or less where these landmines were placed, sometimes the same groups would go and victimize the local population because they thought that they were the ones telling the government where these landmines were. So that's why this is something that has been documented by several NGOs during this period. We're going to try to understand this with a correlation at the municipality level. We do not have good data on either victimization nor attacks at the geographic level. So what we're going to do is this correlation between demining and the incidence of conflict and forced internal displacement. Once we do that, basically the usual adding fixed effects all over the place. But what we find is that after military, when there is an increase in military demining, there is also an increase in victimization, and this effect is 3 times larger in the case of the conflict period. We also find an increase in forced displacement, and this is more or less twice as what happens in the peace period. And we also find an increase in the attacks. What is interesting is that after humanitarian demining, there is a decrease in victimization as well. This is just a correlation, but we think could be informative of what would happen in the dynamics of conflict and the relationship with demining. Then in terms of deforestation, as I said at the beginning, there are some agricultural activities that have been related to deforestation and also with conflict. And most of them take place in areas with big landowners that push people out of their lands and do some illegal deforestation to clear land so they can enter there and start planting oil palm or taking their cows there and so on. To try to understand whether this is behind our deforestation results, what we create is a measure at the buffer level of the suitability for different type of crops or activities. we're going to use oil palm, cattle ranching, banana, white banana. In Urabá, this was a big deal between the illegal groups and banana cultivation. So we basically split the sample into high and low suitable, and then we estimate our model there. What do we find? We find that most of the increase in deforestation that we find is coming from these areas with high suitability for these extractive activities. We do not find any effect in humanitarian or any differential effect in humanitarian demining, but for the other two with the military, we find the same. We also look at what happens in terms of fires. We find that there is an increase, well, I hear a small typo. We find an increase in fires after this humanitarian demining takes place, this military demining takes place. And we also look at illegal gold mining, again, typo, sorry. And we find that most of the increase in illegal mining is after this military demining that takes place in these areas. Then finally, something that we try to analyze is, as I said before, these landmines were placed around these coca fields, or to protect the coca fields by these illegal groups. And one of the main flagship programs or policies that was implemented after the signing of the peace agreement was this illegal crop substitution program that basically allow farmers to move from coca to legal crops. And to estimate this, basically we look at the municipalities where this PENIS program was implemented, and we compare the ones where it was implemented with ones that are not. So far, we do not have georeference information for this, but we are trying to get it to do it at a more finer grade. And what we find is that most of these effects in humanitarian demining and military demining that we were observing in the drop of coca cultivation is coming from these municipalities that implemented PENIS. Of course, this is a low number of observations, so this is just suggestive, but I think it makes an interesting point that there could be some coexistence or mutual reinforcement of different policies, and this could be one potential way to reduce the production of illegal drugs. So just to conclude, in this paper, we study the socioeconomic effects of landmine demining, exploring different types of demining, and in different periods. We find positive and large benefits after humanitarian demining. We find negative or null effects for partial demining during these peace and conflict periods, and this can partially explain by the increase in conflict and also by the suitability for extractive activities. We do a partial equilibrium back of the envelope calculation that basically suggests that after humanitarian demining takes place, GDP increases in the municipality by 0.8%, and this is using the elasticity from nighttime lights to GDP from the Henderson paper, kind of the seminal paper on nighttime lights. And if we do a cost-benefit analysis, we find that for any dollar that is invested in humanitarian demining, there is an increase in the benefits at the local level of $7, and this is only accounting for 1 year after the humanitarian demining takes place, so probably it's an underestimate, and also we are not taking into account the educational benefits that we are observing. So I think these results point to a necessity of a comprehensive and more ambitious demining campaign that can combine demining with other policies such as state building efforts and local investment. Thank you.
Okay, thanks very much. I don't think we have time for the questions and answers. We are already on Christine time.
Sorry.
But
Sorry about
what I suggest, no, but that's okay. That's okay. What I suggest is that people who have questions for Monu just type them in the chat, and he can answer there, or his co-authors. And in the meantime, Christine can start as well.
So thanks, Arvin, for the introduction. Thanks, LAMES, for the prize. It's a pleasure to be one of the presenters at the Simon Lecture this year. And I'm going to present the econometrics paper, a paper about the econometrics of network that's co-authored with a former student, Luis, and a former colleague, Vladimir. And the idea of this paper is to build a model of network formation that allows us to identify and estimate homophily that is due to preference and homophily that's due to meetings. And I need to say that I'm really bad answering the chat during the presentation. So please, if you have a clarifying question, raise your hand. I'm happy to answer during the presentation, okay? And if you have a question, I can answer the chat later after the presentation. So what's homophily, right? Homophily is the tendency that you have to connect with similar people, right? And it's a feature of both basically all social and economic networks. And the literature has been modeling homophily in many of the recent papers, but there are a few papers that try to distinguish between homophily that's due to preference, to choice, and homophily that's due to meeting, to the opportunities, right? And why this is important? So Jackson has many papers about that, and he has a new paper really recently telling the importance of understand the structure of network and the structure of homophily, especially if we're trying to understand some kind of policy implications, right? Some kind of policy implications are related to the structure of a network, especially it's really related to the homophily that's in that network, right? And there are a couple of theoretical models that try to make the distinction between these two types of homophilies. There is Kurani of 2009 and Bramulendo of 2012. However, all these models have some important drawbacks that kind of limit when they can be used. So I had a private problem that I couldn't use any of the models. So that's why you build another model that could allow us to investigate our applied problem, right? So what are the drawbacks of the two models that I told you? The first of all, they only analyze the long run and steady state behavior. They don't tell much about the transition dynamics. That was something important for our application. And the matching process in these models are very simple in the sense they are pure probabilistic, or they are based on a limited set of payoffs. So what you try to do in this paper is to identify and estimate a network formation model that incorporates both types of homophily. We build our model based on Malley 2017, but you're going to allow to have a more general payoffs and the meeting process. You're going to identify the meeting parameters, especially are really interesting in identify the homophily parameter inside the meeting process. And you're going to analyze of equilibrium behavior, right? And you're going to apply this model to the context of Brazil. So you have an interclassroom network in Brazil, and you're going to analyze some contrafactors to show the importance of understanding the structure of a network when you want to understand the implications of, for example, a tracking policy, right? So that's the main goal of this application. So that's the agenda of my presentation. I'm going through the theoretical model. I'm going to talk about identification and estimation. And if I have time, I'm going through all the application, right? But I'll go through the theory before, and if I have time, I go through the application. That was the motivation of the entire paper. So it's a game, right? It's a network game. So you have a finite set of agents. You have an agent inside a network, right? Each agent is endowed with a vector of exogenous characteristics W. But what identifies the network is the vector of all the agents that it's inside the network. That you call it X. Right? So X is basically the agents vectors, the matrix that stack all the agents vectors for that network. You're going to assume it's really strong, but you need these assumptions that exogenous characteristics are drawn before the beginning of the game, and they remain fixed throughout all the game, right? And time is discrete in this game. So it's a very simple game. So at each round of the game, the students' relationship are going to be described by a direct network. What's a direct network? A direct network is just like, I will say that there is a link in my network if I is connected with J. I don't need J to be connected with I to form a link, right? Our model can be built also in an indirect network. You can do that, but since my application, you collect data about direct networks, I will keep the direct network framework in this presentation, okay? The information on the network is going to be stored on what you call adjacency matrix G. What's the entries in this matrix? I'm going to Gij is equal 1 if agent I nominates J as a friend and 0 otherwise. All the diagonal matrix is by assumption 0. I cannot connect with myself in this model, okay? And you have this fancy G as the set of all possible adjacency matrix in this network, okay? The agent is going to derive utility from being in that network with that covariates. And the utility in this model may depend on the entire matrix of covariates, not only the covariates of I and J. For example, if J is my only friend, right? It can be depend on the entire matrix of X. And how they are going to form or not a relationship. You're going to assume that the agents are myopic, so they form or maintain a relationship, or not form or not maintain a relationship based on the current utility that they have. And so the process is like this. At each round of the game, a matching process happens and select a pair of agents, I and J. This matching process is going to be described by an invariant function, rho, that depends on the previous network, little j, and on the characteristics of the network, little x. So this rho is just the probability that the pair I and j select when the covariates are little x and the previous network was given by the adjacency matrix little g, okay? After the matching process, after I and j is selected by the matching process, there is a pair of shocks that are drawn, right? I have a pair of shocks because I have a shock that go for the taste shock of I and j when I and j maintain or form the relationship at time t, and I have a taste shock when for the case that they did not form or maintain the relationship. Okay, that's why you have a pair of shocks, because you need to have a pair for each state. Okay, the shocks are unobservable by the econometrician, but the agents have full information in this game. Okay, you are going to assume that the shocks are IID draws from a node distribution. You need that for the equilibrium. Okay, so after the pair I and j select by matching process and the shocks are observed, I get to choose to form or not a relationship with j. Since the agents are myopic here, they are going to form or maintain the relationship based only in the level of the utility they get of forming the relationship, plus the taste shock of forming the relationship. If it's bigger than the utility they have without forming the relationship, plus the taste shock, they will form the relationship. If the opposite, they will break a relationship or not form the relationship. It's really simple. It's a comparison of utility levels, okay? So what you show in the paper? You show in the paper that conditional on X, my network game, the structure of my network game, plus initial distribution induce a Markov chain on the set of networks that I can have, on the set of the possible networks that I can have. This Markov chain, I'm going to represent by a transition matrix, right? What's this transition matrix? In each cell of this transition matrix, I will have like this. The transition matrix, the cell JW, is going to be the probability of transition from J to W. So my current network is G. So what's the probability of transition from another network? That's W. That's each entry of this matrix. So it's a huge matrix with all the probabilities of transition throughout my game, right? But I need to define what's called the neighborhood of the network G. What's the neighborhood of the network G? It's the set of matrices that differ by little g only by one edge. Why? Because each round of the game, only one pair of agents is going to be picked by my matching process. So I can only move to a new network that's in my neighborhood. And that's how you can get the identification. So each round of the game, it's only one pair that's going to choose to form or not the relationship. So I can only move to a network that's in the neighborhood of the current network. Okay, so that's how you're going to play with this transition matrix. Okay, so this is my setup, how identification works here. Okay, in this paper, you have a random sample of networks. It's different from other papers that you have a network that's going to increase, right? Here, no, my asymptotic is going to work in a random sample of networks, and I need to observe my networks in at least 2 periods of time. So I'm going to do the example of 2 periods of time in this presentation. So I need to observe my networks in period 1, that's T0 from me, and period 2, that's T1, right? It's just like 2 periods, that first and second period. And I need to observe the X of the networks. And I have C networks, okay? And that's my setup here. The model doesn't work if you do the asymptotics in a networks, that's going to increase. You need to have a random sample of networks for the model to work here. Okay, so the idea is like my transitional matrix that contain all the possible transitions that I can have throughout my gain depends on the covariates that I observe, but depends on the parameters inside the utility function and the matching function, right? So I need, the goal here is to identify theta, is to identify all the parameters inside the utility function and the matching function, right? I observe the networks in 2 periods of time, but between period 1 and period 2, I can have many rounds of my gain, right? For example, I can have many rounds. So I pick one pair, they choose, pick another pair, they choose, and so on and so forth. Because I can have 1 year apart, 3 years apart, it doesn't matter, right? So tau naught is the number of rounds of my game that take place between the first and the second period, right? And tau naught depends on the model you have in your head, in the application you have. Tau naught can be known or unknown, right? If tau naught is unknown, I will need to identify tau naught, right? The first result you have in the paper is the following. You can identify the transition matrix to the power of tau naught if you assume that all the networks has a conditional positive probability at the baseline. So if all the networks has a conditional probability, a conditional positive probability of happening at the baseline, I can identify this object, right? So if I can identify this object, the main idea here is like, I'm going to identify tau naught. I'm going to try to identify tau naught, the number of rounds that I have in my game between the 2 periods. And then from this object, I will try to identify theta naught, right? So that's how identification plays in this model, right? So what you have from the identification of tau naught. If you don't know tau naught, if you know tau naught, then you can jump directly to identify the identification of theta, right? But if you don't know the number of rounds that take place between the first and second period, that's the case of our application, then the result you have is like, if tau naught is lower or equal to n times n minus 1, when n is the number of agents I have inside my network. If you have this bound, you can identify tau naught by counting the number of positive entries that I have in this matrix, in this object, that's transition matrix to the power of tau naught, right? So if tau naught does not satisfy this bound, then you need to assume that you know tau naught to proceed the identification strategy, right? But luckily, in our application, you have this bound for most part of the classrooms, so you could identify tau naught by counting the number of positive entries that you have in this matrix. Okay, once you identify tau naught, then you need to proceed and identify theta naught from this matrix, right? How do you do that? And then comes the, I think the main result in the paper, that you have identification at infinity approach in order to identify theta. So it's exclusion restriction. So remember that you have the matching function. So you have X covariates that's going to enter the matching function, that you call it XM. And they're going to have covariates that enters the utility function, right? But what matters for me is the subvector of covariates that enters the marginal gains. What's the marginal gains? Is the utility I get from moving from network G to network W, right? So my XUGW is this subvector. I need exclusion restriction like this. I need to have a set of covariates that enters the marginal gain of moving from G to W, but does not enter the matching process, okay? And more than that, since I have identification at infinity, when this covariate attains large value, the probability of moving from G to W goes to 1. This is the first case of identification. I can have the opposite. I can have some instrument that enters the matching function, but not the utilities, the marginal gains. And when the covariate attains large values, the probability that the pair I and J is picked goes to 1, right? So basically, it's an exclusion restriction, an instrumental variable with a identification at infinity based on that instrument. Okay, so identification is like this. You need to have exclusion restriction, and you need to have this part that when the variable goes to infinity, I know that the probability of ij's picked goes to 1, or I know that I'm going to move from G to W. Okay. Estimation. Estimation, usually it's really a problem in most part of the network models, right? And I'm going to explain you all why. But in this paper, you propose a two-step procedure. In the first step, you're going to estimate the number of rounds, because it's the first thing you need to do to estimate how many rounds you had in that game. So you need to estimate the number of rounds you have between period 1 and 2. And the second step, given the number of rounds, you're going to estimate the parameters inside the meeting process and the utility function. Okay. The estimation of the number of rounds is really easy because you have a random sample. So what you do, you estimate tau naught by counting the number of different edges that you have each network between the two periods, right? And then you take the maximum among all the networks. So for example, if I have 100 networks, I'm going to calculate the number of different edges, different links I have in the networks between period 2 and 1, and I'm going to take the maximum of these among all the networks, right? And in the paper, you show that this estimator is consistent when the number of networks goes to infinity, okay? The problem comes when you need to identify the parameters inside the utility function and the matching function, right? So what you do, you take the tau hat as given, right? And then you're going to impose a parametric format for the utility function, a parametric format for the matching function, right? And you're going to try to estimate this beta naught that it's inside the parametric format for the utility function and the matching function, right? The most common estimator is to do MLE in this case. However, in this case, it's impossible to do MLE. Why? Because when you build the likelihood, you need to compute all possible walks that I can have between period 0, the first period, and the second period for all the networks. So even for a small value of tau hat, this is really impossible to do. It's a huge likelihood, right? Simulated GMM and indirect inference doesn't work here because you don't have a low dimension sufficient statistics. So you decide to use a Bayesian approach. In fact, you're going to use ABC here. In fact, it's a variation of the ABC, of the approximate Bayesian computation, right? So the ABC, it's a Bayesian method that's close related to non-parametric econometrics and indirect inference. In fact, you have a proof for that in the paper. But the idea is that you draw beta from a prior, you generate artificial sample based on this beta, and then you are going to compare the true data with this artificial sample. If they are close, you're going to accept the value of beta. If they are not close, you don't accept. So the plain ABC works like that. I'm interested in estimate a function age, right? I'm going to define some level of tolerance. I'm going to define a vector of statistics T. And I'm going to compute these statistics based on my true data, G1, the true data that I have in the second period for my network. That's giving me T hat, right? And then I'm going to proceed like this. I'm going to draw beta, to draw a set of betas from a prior. I'm going to do it many times. For each draw, I'm going to generate artificial sample, right? That's going to be based on the likelihood of the network in the second period. That's going to depend on my baseline data and on X, right? Based on this artificial sample, I'm going to calculate T tilde, right? And then I'm going to accept this beta with certain probability that depends on the difference between T hat and T tilde and on my tolerance level, right? When I have the set of betas that were accepted in this algorithm, I have a posterior and I can calculate age based on this posterior distribution of betas, What's the problem of applying this ABC here is that you don't have a vector of sufficient statistics in this model, right? In fact, if I play with the ABC, I need to play with the entire network, right? But you are using IID sample, right? You have the assumptions that you have IID sample of networks. So to alleviate this problem of the curse of dimensionality, you use a variation of the ABC, the expectation propagation that's proposed by Barthelmy in 2 different papers. And the idea is really simple. The idea is like, since everything is IID here, my joint likelihood is a product of the likelihood of each network, right? So why you don't approximate like each network in each time and do some kinds of updating to avoid this problem of dimensionality, right? So that's how you're going to do here. So you're going to use, that's what you propose in the paper. You propose to use a Gaussian prior, and then you propose to use a Gaussian approximation for the likelihood of each network. And then you proceed sequentially, right? So for example, I start from network 1, and I do the approximation from network 1, and then condition on what I got from network 1, I proceed to network 2, and so on and so forth, right? I need to do this. I need to pass through all networks until I get some convergence criteria, or until I do a number of passes through all the networks. Okay, so that's step 2, right? And you show that this algorithm is really close to think about indirect inference if you want to think more about a frequentist work. Okay, now I have 5 minutes, so I'll do a little bit of the application, right? So what's the application? The application is like you have data from schools in Brazil. So you have data on 3rd and 5th grade students in Brazil, right? You collect this data in early and late 2014, and you ask the students about the direct network, right? So you ask the students to nominate up to 8 friends within their classrooms, right? And they're very young students, and they didn't have 8 friends. In fact, nobody reached 8 friends at this point. So 8 wasn't a big deal for us, right? So at the end, you have 161 networks. There are classrooms, and this size of students, right? The first thing you did with the data is to did some reduced forms to see if the students connect with similar people, if you have evidence of homophily in this data. And you have a very strong evidence of homophily in this data. I'm not going to show you because I don't have time. And then the idea was like, oh, but can you tell if this homophily is due to meeting, which means that they have opportunity to meet similar people, or is due to preference, right? And that's the big questions that we want to answer. And this is important to understand the effects of tracking policies. So what you did, you used our estimator for the number of rounds, and luckily in this data set, most part of the classrooms satisfies the bound. So you didn't have a problem with the bound, and you could proceed with using our estimator for tau, and you got 76 our tau hat. So this is the number of rounds that happen between period 1 and period 2. You parameterize the meeting process as it's almost a logit, so it's proportional to exponential. When inside this meeting process, I have a vector of covariates, right? One thing that you have that's different from the literature, since I have a panel, I allow the meeting process to depend on what happens in the previous network. So I'm going to, the probability of picking I and J in this meeting process will depend if they are connected or not in the previous network. And here comes my instrument, right? If they are not connected in the previous network, you're going to assume that the distance that each student have in the class list changed the probability of meeting. And this instrument makes sense in this data because you are using a data from a program, an educational program, when students work in groups, and the teachers select the groups based on the class list, right? And the idea is like this, the distance in the class list is going to affect the matching process, but it doesn't matter for the utilities of the individuals, right? And of course, when they are far away, for example, the names are far away in the class list, the probability that they meet goes to 0. That's the assumption, the identification assumption here, right? W is the vector that includes distance in gender, age, measures of cognitive skills, and non-cognitive skills. I have 2 minutes, so I will be really fast. So the utility function, it's built on Mali, right? So the utility depends on who agent is connected with. I is connected with K, so this is a direct link. It depends if K connects with I. It depends on how many friends K has that's not friends of I, and depends on the popularity of I, the friends that I has that's not connected with K, right? And you do the method like that. You assume a Gaussian, right? So my prior is normal with mean 0, and the standard deviation that you calculate based on the summary statistics. And for each classroom, you simulated 1,000 draws, 100,000 draws, and the acceptance rate is 1%, right? Just to show some results. So what you did is to estimate the mean parameters. So that's the parameter for the meeting process. So you see that the instrument, it's significant and in the direction you want. And you see a lot of homophily in preferences in this data. So you see that when you look at the component of the utility that is the direct links, the links that the agent makes, you see that you have a lot of homophily due to gender, to cognitive skills, and to social emotional skills, right? And also you see a lot of homophily when you look the friends of the friends, the indirect links, right? So in this data, what you see is that homophily due to preference are stronger than homophily due to meetings. And what you did in this paper is to do some contrafactors showing that the effect of a tracking policy in this context, right? How is the effect of a tracking policy in this context? I'm not going to show you because I don't have time to show all the results, but what you see is that the tracking policy has a huge effect in the short run because you place them in homogeneous groups. So they increase the welfare of the students a lot in the short run, but then it decreases and reaches 0 in the long run because preference is the importance here. When I connect with the people I want to connect, then the policy doesn't change much the welfare of the students. Okay, so the idea of this paper was to build a model that allows us to identify and estimate homophily that's due to preference and homophily that's due to meeting in a network. And you think that this is really important, and that's the motivation of the paper, because to understand some policy implications, right? So the idea is like, if I want to understand the implication of a tracking policy, it's important to understand how people connect inside the networks, okay? And I think that's it. Let me see. I didn't see the question, so let's see.
Well, you're perfectly on time. But Juan tells me that there's no meeting after this one. So we do have even though it's already an hour, we do have a little while for questions and answers. If people want to raise their hands or type them. And in the meantime, I have a very quick question. So when you try to differentiate between the preference and the meetings, is it possible to refine the instrument a little bit? Because I'm thinking that distance on the list, I mean, the list is like a vertical thing, not a circular thing. So the first one in the list will have shorter connections, but that's not true in real life. Because you will have nobody above you on the list. You see what I mean? So I'm thinking if that could be refined and say construct a measure of, like, based on your position on the list, what are the people who you are most likely to be matched with in group activities? And for someone in the middle of the list, you could count like 3 people on top of that person and 3 people below that person. I'm just saying roughly, if you think, for example, groups are 6 students or 4 students. And for someone who's at the top of the list, you will need to count downwards. And from someone who's at the bottom, you will need to count upwards or something like that.
Like it's a good idea because the instrument works better because it will be more continuous. In fact, yeah, it's a good idea. So far, we are using just the distance in the list. So it's a vertical thing, right? So when I'm the top, I can only connect with the bottom. When I'm the bottom, I can't connect with the top. But you could use some circular measure, some distance measure, right? For example, the groups are 4, so you can have 4 students. They were split in groups of 4. So maybe we could do something like that using the 4 students that are close to each other as a measure or something like that.
How do you know that it's group of 4? Doesn't that depend on the specific activity? It's always the same number of people?
It's because you use the data that about educational program in Brazil, and the implementation of the education program was like this. The students were split in group of 4 and work through half of the day, half of the school day, they work inside this group for the entire year.
It's not a specific activity. It's like how they sit in the classroom for the entire year for
these activities. Yeah,
I see. Okay.
So that's how they build this program. So you have this idea. You don't. I think the idea was like because you didn't think at the time that the idea was it would be much better if you could like have data about how the teachers did that, in fact, right? How the groups were formed inside the classroom. But at the time, you didn't have this whole idea of this paper. So you didn't have a questionnaire about that. But they were split in group of 4, and because of this activity, they spend like half of the day in this group. So that's why the instrument works inside this paper. But you're right, maybe it's a good idea. Maybe you could try to use some distance measure that's more continuous instead of the vertical class list.
I'm thinking maybe you could go to a more extreme definition and say, okay, the first 4 are in the same group, 5 to 8 on the second group. This is of course an approximation, but it's an instrument. So there needs to be correlation, but not perfection.
Yeah, it's not perfection because you know that some teachers didn't use exactly the class list because they said, oh, you didn't want to mixture this guy with this guy because you know that they don't get along. And so that's why you're trying to use some instrument that's has some variation, but it's more general than using the group of 4. Especially because 4 was a suggestion of the activity, and you know that in some classrooms they use 5, some classrooms they use 3 when they don't have enough students, right? So you didn't want to use the rule to create the instruments. But thank you for the comment, Irene. I think it's good. You can try to use like more continuous measures here to see if the instrument, but the instrument, it's really strong. So you were happy that when you saw the results.
Yeah. Any other questions? You could ask for questions for Monu too. Well, okay. So thanks to both. These are really very interesting papers. And do we just close this session or something else starts here? How does this work? We just leave this